In Lesson 510, you'll be looking at indirect measurement, and that is one of our projects for this chapter. In this lesson, you will solve problems involving indirect measurement using shadow reckoning, and you'll solve problems using surveying methods. And remember, the essential question for Chapter 5 is, how can you identify and represent proportional relationships? On page 238, you have the definition of indirect measurement, which is a strategy that allows you to use the property of similar triangles to find the measurements that are difficult to measure directly. And with shadow reckoning, two objects and their shadows form two sides of similar triangles. So notice at the example 1, you have some images of a statue and the shadow that it casts, and then the size of you and the shadow that you cast. And in both situations, you create this right triangle that we can use to set up a proportion and solve for a height that we can't measure directly. So we have the tourist height over the statue height equals the tourist shadow over the statue's shadow. And again, we have a proportion with an unknown, so we can cross multiply and divide to find out how tall the statue is. In example 1, got it, we have a bell tower that casts a shadow of 27.6. So you'll notice right here, that's where I have that picture drawn. I have a bell tower and then the shadow it casts. And then I have a tourist right here. Here's the tourist that is 6 feet tall and then casts a shadow of 1.2. So I'm using the strategy of solving with proportions, but I'm also drawing a picture so I can set up that proportion. Here's my proportion, x over 27.6, right down here, equals 6 over 1.2, right here. When I cross multiply and divide, I get that x is equal to 138 feet. So how tall is the tower? The tower is 138 feet. Now I will mention that I could set up this proportion a different way. I could do x over 6 equals 27.6 over 1.2. If I set it up that way, I would get the same answer of 138 feet. On the next page, 239, we have another example, surveying methods. And just to point out here, you always have that video tutor that you can see another example worked out. So I would recommend that if you ever get stuck or want to just hear someone else explain a problem. In example 2, we're given that these triangles STU and VQU are similar. Remember, that's the symbol for similar. And what we can do with similar triangles is we can set up proportions to find out distances. So I don't know this distance, but I could find that out by setting a proportion for 16 over x equals, whoops, I don't think I could do that because I'd have to find out what another measurement is here. So I could take 16 over x equals 10 over 20, and that's what they did over here in the example problem. So coming down here to got it, I have another picture here where it says QRS is similar to URT, and so what I can do is I can take what I don't know, x, right here, and set that over what I do know, which is 60. And then I need to set up another two sides that I do know, 138 and 46. Again, I can rearrange these numbers any way I'd like, as long as I'm going from one triangle to the next or from one side to the other in the same order as I did on the initial one. So when I cross multiply and divide there, I get 180 yards. I do have one more problem for you to work out on your note sheet, and that is number 8 on page 240. There's lots of things going on here, so I'll try to keep this okay and documented for you. So In number 8, letter A, it wants us to find the length of segment GD. And so we can do that by starting with something that we do know. We know this triangle's height is 9, but we don't know this length right here, x, so that's where my x is. We do know that this is 4.5, and we do know that this triangle is 6. So when we cross multiply and divide there, we find out that GD is 12. So this whole thing right here is 12. And we know that this is already 6. Part B tells us that segment GF is congruent to FE. So GF is congruent to FE. And so if this whole thing is 12 and we take away the 6 that we already know, that leaves 6 for this segment right here. And if these are both equal, then these each have to be 3. So in question B, it's saying find the measure of segment BF. So we're trying to find this guy right here. Well, again, we're going to start with what we do know, and that is 9 over 12. We'll do 9 over 12 equals, we don't know BF right here, so that's going to be our x. And then this one right here is 6 plus 3, which is 9. Okay, we can do some canceling here. It'll just make the numbers a little bit easier to work with. 3 goes into 9 3 times, and 3 goes into 12 4 times. Cross multiply, 3 times 9 is 27, equals 4x, 4 times x. When we divide by 4, we get x equals 6 and 3/4, or 6.75. Finally, we are looking at letter C, and it says the length of segment AD, this whole thing is 15 meters. What's the length of CD and BC? So in this case, I again started with the 9, what I knew for the big triangle, and this whole hypotenuse, which is 15. And then I knew that this was 4.5, and we're trying to find the x value here from C to D. When you cross multiply and divide, you get that CD equals 7.5. Same thing for BC. We're going to take 9 over 15, and then we'll take, to find BC right here, we need to actually just take the 15 minus the 7.5 that we got in the previous answer. CD is 7.5 and AD is 15. So 15 minus 7.5 is only 7.5. So I'm not quite sure here, BC, that's that segment right there. I'm not getting the same answer that they got in the book. So if you find my error there, it's late. I'm making a video at 11 o'clock at night, so I might be missing something there. So if you find my error, let me know. And just remember that proportions are a really powerful problem-solving strategy. We've used it in solving lots of different types of problems in this chapter, and it's one method, but it's a really powerful method because it can be used across lots of different situations. Please let me know if you have any questions and if you figure out my mistake on 8C, and that's it.